So good morning again. So if you recall our discussion from, there are four problems we have seen in the original name sort program. Name sort 1 and name sort 2. So in the name sort 1 program, there are four problems. So number one is, so what are the problems? Can you tell me? Can you remind me? So first one is, so what we are doing is we are 20 characters per name. So we are kind of using something like this: car names 100 20. This 20 corresponds to this max name list, max name length, and names correspond to this. The number of names is given by max underscore list. We used a macro. So the first problem is if the name length is less than 20, then the memory gets wasted. Okay, memory wastage. On a per column basis. So on every row, if you see a row and every row has 20, can hold 20 characters, and if the length of the name is less than 20, the rest of the memory allocated goes waste. Yeah, so other problem is if the size of the name is bigger than 20, then again we are in trouble. So one is wastage, other is if it's bigger than 20, then we will not be able to handle. Yeah, good point, very good point. Uh, so, so greater than 20 problem. The name length greater than 20, it's a problem. So the next problem that we have is, if the number of names, uh, in the list is less than 100, there is a memory wastage. And if the number of names is greater than 100, then there is a issue. Number of names less than 100, so memory wastage. Number of names greater than 100, we are in, again, no, we cannot hold it. Of course, there is a problem. The other problem, it's an easy problem to take care, that what if there are space in the names? If there are space in the names, all you have to do is, the scanf function that we are doing on line 11. If you see the read names function, we are using a scanf. So we just have to change our routine to that. So like, for example, you can use get tests or something like this. So get tests, we have to check we just have to change the reading function, the input reading function, to accommodate spaces in the names. So you can, that's not a big problem. You can check on it and see how to uh, work with it. All right. It's a good point though, Tanmay. In the last class, what we did is, in order to solve these first two problems, we changed the data structure to char star. We used an array of pointers. This is what we did. By using an array of pointers, so we read a name and then we figure out the amount of memory that needs to be allocated to that name. We allocate memory to it in the heap, and then we say names of I is equal to, and we will have a pointer to it. So what we do is, using malloc, you allocate a chunk of memory in the heap, and we say names of I points to this. This is what we did in the last class. So here, if you check the read names function, just I would like you to recall how the read names function works. So the scanf function on line 15, it reads the current name into a, it reads the current name, uh, it reads the name and stores it in an array called as current underscore name. It's a local array. And then on line 16, we are computing the length of the string, and then we on line 17 we are allocating a chunk of memory from the heap, and the pointer to that chunk of memory, the address of that chunk of memory, the base address of the chunk of memory, we are storing it in the names of the ith element of the names, and then we are copying the current name to that chunk of memory on the heap, and then we keep iterating. And then you can see on line 20, if the number of the size, the number of names is, we cannot read more than 100 names. Once we reach 100 names, we kind of break from this routine and return. This is what we are doing here. So now we would like to, yeah, that's true. Current underscore name also have an upper bound for string length. So we can assume reasonable thing. Like for example, let's assume the max name length is 100. So here no memory, not much memory wastage is there. We can, how do we break away for less than, you press Control D on whilst that we have seen it before, which indicates an end of file symbol. Control D, then or any other, yeah, you press Control D, then you will come out of, it indicates an end of file symbol, and you can come out if the input is less than 100. So now we want to go to the next version. We want to solve the problem where we don't know the number of names. We don't know the number of names. And so we want to work with it. So the idea here is you start with an initial estimate. You start with an initial estimate. Let's say you think that maybe I need 100. I may end up reading 100 names uh, in the list. And then but after you read 100 names in the list, there are still more names. So you want to increase the size of your array. You want to increase the size of your array. And when you want to increase the size of your array, there can be many strategies. One strategy could be like, for example, from 100 you go to 200, from 200 you can go to 300, from 300 you can go to 400. Like this, you can keep increasing the size of the array. There are other strategies. There are so many strategies you can follow. You can say from 100 I go to 200, from 200 I go to 400, from 400 I can go to 800, things like that. So everything has its, and there is no clear answer for these things. So it very much depends on the context. That's all I would say. Today, what we will do is we will use this simple strategy where we know, like initially we start with, we can go from 100 to 101 to, there are problems there in, I will tell you what's the problem. So yeah, 100, 200, 300, 400, like that. The question is, why can't we move from 100 to 101 to 102 to so on and so forth? So I'll answer that question. Good question. So now let's see how to write this program. And So here, so this is, let's see how you have to help me here. Uh, the first thing that we have to do is, so this is what we did in the on line 60. That is our first version 1 of the program. And now what we are going to do is we will comment out this, and this is version 2 of the program. So now we want to uh, char star star names. So this is our this will be the version 3 of the program. Okay. I'm just thinking whether we should use char star star name or whether we can just get away with char star names. Let's see how it goes. Uh, yeah. So yeah, so this is what we are going to do. So what we initially do, so this is our read names function. So this is all we do. And then, so we pass read names. No? So here on line 65, we go to read names here. Uh, I have to confess, I myself am a bit nervous in writing this program. So let's see how this goes. So initially what we do is, yeah, so I don't know, let's say names. So you want to do an malloc on mags list. So let's do one thing, init list. The initial size of the list, let's call it as init list. Let me make it, let's say 10. So Krishna Praneeth is probing me, just following init list. So unit list star, what should be the size of char pointer? Where is the current name thing is gone? All right, phi is equal to init list. Let's see if this works. So what does size of char star give? So size of, what is char star? So what will size of char do? I will explain the modifications if it works, Tanmay. So what will size of char do? Size of char will, uh, it returns 1. And what will size of char star do? So char star is the type of a variable which holds the address of a character. So, and that could be 8 bytes or 4 bytes. Yeah, so it could be 8 bytes with high probability. Will line 19 work? Let's see. There are no compilation errors I'm getting. 8 bytes hexadecimal address, exactly. Yes, Brian. So GCC Okay. Yes. We got a segmentation fault. So let's do a GDB on see what is going on. So we don't need Valgrind here. So Valgrind is not going to tell us what's the problem. So because we have how many names are there? 3, 6, 3, 6. Oh, 11 are there. Ah, okay. Thank you. You made my life easy. Huh, not really. Oh, I didn't compile the program again. So let's make this equal to, if I underscore init list, let's make this 20 and see. Okay, so now we are all set. We are in a rocking state now. GDB a.out run less than names.txt. I don't know whether this will work. Oh, okay, okay. So I think we are not, it's not bad. We are, the problem is not in the, so the problem is not in the read function. I thought the problem is in the read function. The print names function is, yeah, print names. Yes, read names, print names. Sort names as well. Huh? Okay. Somehow sort names work magically. Yeah, Varshita has a good question. Shouldn't it give the problem that the parameter names are looking different? Oh, it didn't reach the, but the question still remains the same. Yeah. Run less than names. See, it is interestingly, it is showing names is equal to 0. I think we'll have understood the problem. Okay. Yes, yes. So here, if you see the seg fault, it says we called print names with 0x0. Yeah. So why is it the case, guys? Why is it the case? Can anyone tell me? why is it why are we calling print names with names is equal to 0x0? So on line 68, so on so we are passing read names here. We are passing read names here. So yeah, so here if you see on line 64, we are declaring names and we are calling read names with names as parameter. So it's not used. It's who can tell me what's going on here? On line 14, we are doing an malloc, and but what we are doing is, we are not modifying names because names is passed as a call by value parameter. So on line 14, although we are allocating a chunk of memory and assigning it to names, it's not being reflected back. So what do we need? We need star 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 names. Okay, so that's why I said I'm nervous. How many of you understood it? So star names. What I would like to do is, in order to make it p names. So Dhruv is asking me to repeat. So as I told, no, I will repeat it if it works. No, otherwise, what's the point in explaining a wrong logic to you? So let's figure this out together. You play along with me, and if the story concludes well, then then we will make a fairy tale out of it and tell it. I need to do 3 stars in main. Huh? I don't need to do 3 stars in main. I need to pass a pointer to. Awesome, awesome. So confused and all. So let's see how this is going to be interesting. Yes. Okay. So now I can make a fairy tale out of this and tell the story. Okay. So yeah, what's the point? Um So number one is, so names is a, let's try to see what is going on. The program is not yet complete, but till now what happened, we will see, and then we will. So number one, so line 66, what does names is a pointer to a pointer. So what we are looking for is this. What we are looking for is, we still want to work with an array of pointers. This is an array of pointers. And each of this array, they points to some chunk of memory in the heap. I am just using this, no, some kind of cloud-like thing to indicate that the memory is coming from the heap. So if you look at the data type, if you look at the data type of this, I will use a of each of these elements. What is the data type of each of these elements? Can you tell me? Let's take it one step at a time. Of this element, this element, this element, this element, what should be its data type? It should be a. It's not an L. I'm just wanting to indicate no this particular element, the whole thing. It's a pointer. It's a char star. It's a pointer to a character, because this whole thing that you are seeing in the cloud, it's a character array. Are you with me here till this point? They hold the address of a character, but no, if you take a string, so if you know the address of the first character of the string, then you know the whole string's address. Are you all with me? Okay. So now, if you want to define a variable which holds the address of the base of this array, okay, or rather the address of the first element of this array, what is its data type? What is its data type? So its data type is char star star. And if you know the address of this base element of this array, then you know the address of this, you know the address, if you know the address of the base element, then you know the address of this, you know the address of the second element, the address of the third element, address of the fourth element, so on and so forth. So on line 66, that's why we have char star star names. One thing I want to tell you, in C, there is no string data type. There is only character pointer, but using a character pointer, we realize the strings. Strings is an abstraction, exactly, because there is no string data type in C. By itself, there is no string data type. What is a string? A string is a array of characters followed by null character. So it is not given by the language. We are not given, we are not, its strings is not given by the language. It's not like we don't have, you cannot say string some variable, it's not there. So from characters you build strings. So you never say that something is pointing to a string. Okay, so so here you point to a character, but that character, if you follow that, but that character could be beginning of a string which ends with a null character. So now on line 69, we want to write a function called as read names. And you want to pass this names parameter, this variable to it. And it will read an array of, it will create this data structure. It will create this whole thing. It will create this whole thing. And it wants to, read names it wants to do two things. One is it wants to return the number of names it has read, and it also wants to give the base pointer, base address of this array. No, this is not an array of char stars. It doesn't have /0 at the end. No. Strings, only when we are working with strings, we have to see that, a string ends with a null character. So this read names function, it wants to do two things. Number one, it wants to create read names and create a data structure like this. And incidentally, this whole data structure, the one which is looking like an array, this is also coming from the heap. This whole thing in the blue, it is coming from the heap. Are you with me here? What read names wants to do? Read names wants to create this whole data structure in the heap, and it wants to give a base pointer to this to the first element of this array. Through that, it is possible for us to access everything in this data structure. But if I just pass names as an argument to read names, what will happen is any modification to name, since it is by call by value, it will not be reflected locally in the function main. Are you with me there? Remember? So that is the reason why we see. Let's say if I pass just read names. So read names will create this whole data structure. Read names will create this whole data structure. Uh, it will create this whole data structure, and then it wants to, in the names variable that we are passing, it wants to assign to that names variable the base address of this array. But the problem is if you just pass names and so and if names we are passing a value. So remember, it's call by value and call by reference. It's not any modifications that are made locally in that read names function to the parameter. It will not be reflected in the main function. So we want to pass the address of this object. So we want to pass, what do we want to do? So what we want to do is, we want to pass the address of this object. Whatever the address of this object, we want to pass. If the address of this variable is passed, then read names will read the whole thing. And while coming back, let's say the base address of this is equal to 100. It will put 100 in this, and then it will return the number of names read as a return value. And the whole thing is available for us. Are you all with me here? We will go to the read names, but do you understand what is the purpose of read names? The purpose of read names is it will read this whole, all the names and store it in a data structure which stays in the heap. And the base address of this array, it wants to store it, it wants to return it. Okay, how does it wants to return it? By modifying the parameter that is being passed. So we pass the address of this of the object, that is underscore the ampersand names. So what happens is, so what should be the parameter type for read names? What should be the parameter type if you take address of names? Parameter type, not the return value type. Parameter type. What is the type of names? It is star star. So the parameter type should be char star star. It's a pointer to a pointer to a pointer. Yes, yes. Frame summarized it, so you may want to read it. Are you all with me? Can you take some time to think about it and see if you're all doing good? Okay. Are all happy so far, at least? Varshita has, how does the computer store array of strings by storing base address of each string? Can you show the code for need names? Okay. So now let's scroll up. So this is the read names function. So here, so far we didn't completely, as someone pointed out, we didn't completely accomplish our goal. It's not yet done.
Thank you.
Good. So now let's look at, please pay attention now. So we will take things on line 15. What are we doing on line 16? On line 16, what is malloc doing? So we are telling malloc that uh, we are telling malloc that we need an init list. Okay, so what is the size of init list? It is 20, 0, 1, so on. And the size of each element is the size of a pointer to a character. The size of each element, it should be big enough to hold a character pointer. Are you with me? Please follow my line of thinking. Uh, are you with me here? What malloc is doing? We are asking malloc to allocate an array of 20 elements, and the size of each element, it is a character pointer. That's it, should be able to point to a character. That's true. We are asking for space to store an array of pointers. Are you with me on line 15? I think you should hold off. I think if you just follow my line of thinking, if you skip things and ask me questions, then everyone will be confused. All right. That's what we are doing on line 15. And what does it return? So it returns the base address. And but if you actually think about it, finally what goes to malloc is just a number. It's a single number, 40, 50, 60, or whatever it may be. This whole chunk of the memory, we logically view it like this. Again, this is an important point. Are you with me? I want you to not ask questions, hold off your questions for some time, please. Okay. So you have to follow my line of thinking, otherwise we will be lost. If so, focus. So if you go look at what is being passed to malloc is some number, and malloc gives that amount of memory. That amount of memory you view as it as an array of pointers, as an array of character pointers. And what is the base address of this? The base address of this, and it returns the base address. And the base address of this, it is a, this is in the earlier discussion, we said this is a character pointer. So this should be a pointer to a character pointer. So that's why its type is char star star. Line 15, that's what line 15 says. This is of type char star star. And this is of type char star. Again, asking question, line 15, are you completely with me on line 15? Now, look at line 16. This base address, we want to pass it back to our calling function. So what we are doing is, what we are doing is we are saying star p names is equal to names. Star p names is equal to names. The question is why can't we do star p names is equal to this? We can do that, but I did it for some other reason actually. But are you with me on line 16? On line 16, what does p names contain? P names is the address of the names variable. P names is the address of the p names. If you see p names contains the address of this names variable. So we are modifying that thing in, yeah, what is that we are doing? So we are modifying that memory location using line number 16. So star p names is nothing but no, it contains the base address of this array. It will be stored in that star p names. What is star p names? It's an alias for names variable. Remember what did we pass? So we passed from the way we passed this thing is we called, just want to make it clear so that you'll see on the same screen, we called it as from the main with this, and names is a char star star names. This is from the main. This is coming from the main. Sushil, you are stuck with the same question. Could you please hold off that question, please? I want you to understand what is happening on line 15 and line 16 completely. Are you all with me on line 15 and line 16? There is one question. So line 16, what you don't understand, it's very simple. There is a variable, there is a names variable which holds the base pointer to this array. And we want to, whatever the new chunk of memory that got created in the heap, that address we would like to reflect it in these names. So that is why we are calling this read names with an address of names. And sorry. And star p names is equal to names. Okay, it's star p names is an alias for the names variable. Alias means whether you use star p names or names, it's the same, because we pass it to, no, currently p names is holding the address of the names variable. That's true. P names, no, star p names doesn't contain the address. Star p names contains the address of names, not star p names. P stands for parameter here. Oh, okay, okay. I see what's the problem. Okay, okay. Yeah, I think, okay, guys. So when I say, my bad here, the names here, when I say names, no, like here, when we see the names here, yeah, main dot star p names is equal to names. Okay, Vivek gave a brilliant thing here. This, sorry. Uh, So let me see in a different, I kind of, there is a little bit of thing. So there is a names in the main function. Star p names refers to that, and then there is a local variable names on line 15. So it is equal to main dot names is equal to names. That's what it is. So line 16 is equivalent to line 17. Okay, let me do one thing this here. Let's wait for a moment. ptr names. It's a pointer to names from the main function. On line 9. I don't know, let me kind of make this clear pointer. Let me let me take a step back and see where you are. Can you take a moment? How many of you are with me? Can I see? Maybe I'm overdoing it, so I just want to check. Okay. So this is and now on line 18. So line 18. So this is one question which Sushil has been worried so much. On line 20, line 21, line 22. So line 22, it is names of I. This is what Sushil is worried about. So names now contain the base address. This is names, right? So this is names. It contains the base address. So remember, in one of the classes I told, names of I, it's nothing but it gets translated internally as names plus I. And since I being a, so the amount it gets incremented depends upon the size of the character point. So this is so yeah, star names of I, you go read the ith element in the array, you copy there, and everything stays the same. That's all. That's all we have so far. So if you're all with me till now, and then so this is what it is, and now what we do is let's go clear. So and then so you get the number of names, and you call print names function, you call, you do sorting, and everything remains the same. Story all remains the same. But one thing we still didn't yet solve the problem is if I is equal to init list, that is the number of names that is being read is equal to 20, or no, whatever that init list, then we are coming out of it. So now we want to solve this problem. So how do we don't want to break, but instead we want to solve this problem. So how do we solve this problem? So can someone help me out here how realloc works? So we have to use a function called as realloc. So let's read the man page of realloc, man realloc. So if you see man realloc, so it takes a pointer to an existing object and its size. It takes a pointer to an existing object. So and then we have to pass one more parameter. What is the size of the new array? So let's say, like for example here, so let's realloc array. Void star pointer means it can be a pointer to anything, so it doesn't yeah. So now let's see, uh, let's try to. So what realloc it does is it realloc the initial before that what we have is names, and what we would like to do is we want to use int current size. Unit list. Uh, if I is equal to um, why not use incremented value of I to So did you see what is happening? So for realloc, we pass names, the original block of memory, which we would like it to expand. And we give the expanded size as the second pointer. So what realloc from my understanding does is, like for example, this is your heap. This is your heap. So let's say in the heap, originally names is this chunk of memory is allocated, and if you ask realloc to increase its size, if you ask realloc to increase its size, it tries to expand it here itself, and if it's not able to expand it here itself, then it tries to find an alternate place where it can allocate that much amount of memory, and it copies everything there. Are you with me on the increasing how realloc works to some extent? So what realloc, this is our original size of memory, and we make a call to realloc, and realloc with the increased memory size requirement. So realloc tries to expand the memory wherever it is has been initially allocated. But if it is not possible, it copies the whole chunk to a different place. Let's say this is the different place. This is the new place. Because the memory chunk has to be contiguous. No, it has to be contiguous frame. Otherwise, the things doesn't work. The memory block has to be contiguous. It tries to expand the memory block in place that is at the original position. If it is not able to expand it the original position, it tries to copy the whole thing, the old contents to a new place where it is possible to expand. What if the size is lesser than original? Read man page. Good question. So what if the size passed in realloc is lesser than the original size of names? So one thing that I want you all to learn, no? So is, oh, you have a class, huh? Oh, okay. Now you have a new, uh, okay. Sorry. Okay, then I think, okay. So let's stop here. So we will continue this discussion in the, I cannot take my sweet on time from now onwards. So we will continue in the next class. Okay, we'll catch up with this thread. I'll post this code. I want you to think about this code before you come. Okay, so bye.